Today we'll learn about projection. So Spring Data JPA provided projection and we can use that. So before we start using it, let's learn about projection. So projection is a technique of selecting only specific columns from a database entity instead of fetching the entire entity. So you have a database table which has 10 columns and the corresponding entity you have in your code base. Okay. So in code base you have 10 corresponding fields with respect to the columns. So suppose out of 10 columns, you wanted to fetch only two columns. So that time, what we do, we just fetch whole entity, the entire entity we fetch, and we use only those two columns which is required to us, right? So even though we do not need all the columns except those two columns, we still fetch all the columns. But instead of doing those things, I mean, fetching the entire entity, we can use projection to fetch only required columns, right? So that is what projection is. So in projection, you can fetch only required columns, no need to fetch the entire entity. Okay. So this is all about projection. So what is the benefits of using projection in JPA? So the first one is the performance. As you know, if we fetch only two columns instead of entire columns, definitely the performance will be increased. And what is next is flexibility, right? So you have fetched only two columns, right? Instead of fetching entire columns. That way you have more options of managing the data, right? So in case you have fetched entire entity, you will get the entity object instead of the object that you required for two columns. So that is the reason. Advantage is flexibility. Memory efficiency, definitely. If you fetch two columns, it will take less memory than entire columns, right? Simplifies data transfer. Once you fetch the two columns, you have your own object having two fields. And if you want to transfer that data, you can directly transfer the data what you got from the projection. So that simplifies the data transfer. Apart from this, there are various types of projections are available. Interface-based projection, class-based projection, dynamic projection, open projection, and closed projection, right? So we'll go through each of these types. We'll do some example using this interface-based projection, class-based, dynamic, open, close. Okay, so let's go one by one. Okay, now let's start with interface-based projection. From the name itself, you can get to know that we are using interface here. Okay, so here we create um, interfaces with some method matching with the table columns. Okay, so I have created this Spring Boot application to demonstrate this all the types of projection. So let's go through it. I will show you what are all the projections so far we have created. So before that, I would like to show you my Spring Boot application pom.xml file so that you would get to know what are all dependency or what kind of project we are using here. So if you see here, very simple application. Okay, so we have used Lombok, we have used Spring Data JPA, MySQL, and Spring Boot Starter. These are very basic dependency required for a Spring Boot application with a database connection. We are using MySQL. Okay. Okay, nice. So what we'll do, I will go through the entity first. What are all entities I have created? After that, we'll go through the projection what we created. Right? Okay. So I have this product entity and this category entity. We'll go through it. So this product has three fields: ID, name, price, and another join column is here with the category. What type of product is that? Basically, we will get to know from the category name. Okay, so we'll go to the category now. So in category, we have only two fields: ID and name. Okay, so these are the basic two entities we have created so far. Okay, now I would like to show you my Spring Boot application.properties file. So in this application.properties file, I have this main method. As usual, we have this main method. Apart from this, I have this command line runner run method just to write the proof of concept thing here. Okay, so I will get through it. Okay, now we'll start with the interface based projection. Okay, so first I will go to the first query which I have written actually. Okay, so this one is find basic products by category name with custom query. Okay, I will open this one. Okay, so this is a query who has custom query. Okay, so in custom query, what we have, select product name, product price, and category name. These are the three fields we are retrieving from the tables. And this is a joint table. We have product and category we have joined together with the help of category ID with product category ID. Okay. So by joining these two tables, we're fetching the data from both the tables basically. From product we are getting name and price, and from category we are getting the category name. Right. So basically we are fetching three fields. Okay. In total we have more than that. In total, if I would go here, product here I have three fields, ID, name, price, here three, and if I go to category here two, total five. But I'm interested to fetch only the three column name, not more than that. So that is the reason I have used the projection, and this is interface based projection. So interface based projection, if you see, it is not just a normal object. It is an interface which has three methods, and all these three methods are matching with the table name, table column name. I will open the entity here. It is the entity. If you see name, here we have name, and sorry, it is the product. Product is here, name and price there, right? So we have same thing, get name and get price. And for product, sorry, for category we have only name is there and ID is there, but we need only name. Okay, so we'll try to fetch that one. So how we are fetching? Get category name we are fetching. Okay, why I could have written get name, but I have not written, because the reason is I will go to the product. First I will do get category, then inside that I have the name, right? For that reason I have written get category name, right? And all the joins are mapped in the product. If you see here, there is no joins here, but here all joins are here. So all the joins are owned by the product. Okay, fine. So now we got to know how to create a projection using interface. This is called interface projection. We'll create an interface, and whatever the columns required, we'll just put all those methods matching with the column name. That's it. Okay, now we'll go and try to execute that one. Okay, so basically what we are expecting product name, product price, and category name. Okay, so all these details are already there in my database. Okay, I'll just execute it. So everything I have commented here, because one by one we'll uncomment and prove the concept. Okay, see here what you are seeing null and price and the category name. Okay, we'll see why we are seeing null here. Okay, we'll close this one. Okay, we'll go to the repository. This is the repository. Okay, here we have product name. Okay, if you see here, this name and the projection method name is not matching. Here we have get name, but here we have product name. Both are not matching. So that is the reason we are seeing null there. Okay, so what I will do is I will just write it as name. Okay, now you execute. Okay, now you are seeing the product name. Right? That is absolutely correct. Now close this one. So one more thing, why I have put the alias name here? Because the actual column name and the alias name is same, but why did I put it here? Even though both are same. So let's do one thing. I will remove it. I have removed it. Okay. I have removed it. So it should work now. Right? So let's run. See, here you are seeing null. The reason here you are seeing null, even though the name and the getter name both are matching. I mean the accessor name and the column name both are matching. Still we need alias name here. Okay. Whenever you are using interface based projection with custom query, you need alias name. That is the thumb rule. Without that, it won't work. So let's rerun. Right now we can see the name of the product, name of the price, and the category name. That is wonderful. Now we'll move to the next concept, that is query method, right? So this query in the repository doesn't have any custom query. So we'll directly run this one, okay? Using the same projection, whatever we have created, okay? Let's see whether it is working with the query method, okay? So I will just uncomment this. I'll put a comment here. Now run this one. Okay, let's close this one. I will comment this as well so that we'll not get confused with the output. Hmm. You can see here we are getting the same result. Okay, there is no difference. And if you see the query generated by the JPA, name, price, name, category name, right? So it is not extracting all the columns and then it is fetching to, no, not like that. It is fetching whatever the column name we have provided in the projection. The same thing it is basically fetching. It is not fetching more than that. It is applicable for both custom query as well as the query method. So that is the benefit of using projection, right? So this is done. So this is using query method. Now we will test another concept, that is here I have uncommented. Okay, now I will comment the above one. Okay, this. So if I go here, find product by category name. Okay, so this is also a query method. But the interesting thing here is we have nested projection here, right? Nested interface projection, right? The reason why I'm saying it is nested interface projection, because there is a projection inside another projection, right? That is the reason it is called nested projection. So here if you see, I have name, price is there, but for category, what I'm doing, I'm using a nested interface, right? And the type of the return type of the get query method is category projection. That is an interface itself. Okay, so let's execute this one, whether custom projection would work or not. Okay, so this I query what I've written, find products by category name. Okay, let's run this one. Okay, you can see here we are getting the expected result. Okay, but there is a catch here. Okay, with nested projection there is a catch. So if you see before, if you compare the query generated by a projection and a nested projection, there is a difference, and the difference is in the query, how JPA fetch data from the table, right? If you see here, from the product it is fetching only the selected column names, only the selected column names. But when it comes to nested projection, it is fetching all the column names, category itself, and whole column name. If you see here, product name, product price, but for category it is fetching everything, right? It is fetching everything. Even though you have provided, a projection having only one column name, but it still fetches the entire columns of the nested projection. Okay, that is a catch with the nested projection. Let's run this one. We already have executed. So this is done. Now we'll move to the next concept. I will comment this as well. Rex V. Okay, I will uncomment this one. Okay. So I will go to the basic one. I will uncomment this one. Okay, let's print the ID as well. Okay. So here the difference here is we are using uh, custom query, name, price, ID. Okay, everything we have used. Also, if you see, there is a difference in the query how we write it here. Okay, so let's run this one. Whether it is working or not, you will tell me. So let's see what is the result we are seeing. We are seeing product name, product price, and we are seeing the category name and category ID. Okay, right. We'll go here. Let's go here to the repository. I have fetched the ID as well as the whole product, right? So let's remove this one. Okay, let's remove this one and try to execute now. Okay, we're getting the same result. There is just an extra column for ID, but already ID is fetched, including whenever we are creating the complete object, it is fetching the ID as well. So there is not much difference to it. So basically, this is all about interface-based projects, and I have demonstrated most of the thing. Okay, I have demonstrated. So far, what we have done. I will just recap. So there are two types of projection we have used. One is the simple one, very basic one. That is, it doesn't have any nested projection, and all the columns are in the same object, right? There is no nested projection here, and the other one is nested projection. Okay. The benefit of using nested projection is you will have an extra flexibility with you. If you want to put um, columns into an object, then you can achieve through it, right? So in backend, what actually happens? I mean, it creates a proxy class for the interface-based projection. Okay, Spring Boot Data JPA does this one. So you need not to implement or create a new implementation class or proxy class. Everything is happened on the backend. Everything is taken care by the Spring Boot application. You need not to worry about it. So that is the beauty of interface-based projection, right? So far we have completed custom query and query method. Both are completed, and we have used the simple projection, interface-based projection, as well as we have used nested projection. Everything is completed here. So we'll go to the doc.text. So we'll go through it. So custom query we have finished. Query method we have finished. Here what I have written, when using interface projection with query method, right? You must use accessor method name same as the column name. That is true. You cannot have different accessor method name, right? Accessor method name should be same as the column name. This one I'm saying this name should be same as the column name, right? Getter name. And when using interface-based projection with query method, with custom query, accessor method name need not to be same as, so it need not to be same as column name. This is actually not need to be same as column name. Also alias name need to be same as the accessor method name. This we already have executed and proved it. Okay. Now next one is when using interface-based nested projection with custom query or query method, you can use any column to fetch data of nested projection. Any column means any selected columns. Okay, that is also we tested. In nested interface projection, you can. So this is not required. Okay, so this is all about interface-based projection. So we'll see next is class-based projection. In class-based projection, so these are the things that we need to keep in mind. So like interface-based projection, nested projection is not allowed in class-based projection. In interface-based projection, we have nested projection, but in class-based projection, we do not have nested projection concept. So we'll go through one of the projection. We'll see how to create a class-based projection. Okay, for that I already have written the few examples. We'll go through it. So if you see here, I'm using this is an example of class-based projection. You have to create a class and you have to add some property, and this property need not to be same name as the column name. The name can be anything, but the constructor what you are providing in the argument name must match with the column name. Okay, without this it won't work. So this is the structure of an class based projection, and we'll go through one example. So I have written a query. Okay, so basically it is also similar queries, finding the products and category from the table. Okay, so what I've written is select new fully qualified name of the class, that is class-based projection class with the argument. These are the column names basically. Okay, these are the column names that we need to pass with fully qualified class name and the argument we need to pass. And later we are doing the join. Okay, product and category join, that is common. Here you are providing the category name and it will fetch, right? So let's go again to the projection. So in the projection, if you see, there is no columns with this name, right? With this name, there is no columns. So these are entirely different column names and different properties, right? But if you see the argument, the constructor argument or parameter, if you see here, these names are matching with the column name, right? And this is the rule here. Suppose you are fetching from two tables, okay? Here is product is there and category is there, and both the tables have the common column is ID. So in that case, how would you fetch it? So here using class-based projection, it is difficult. It's not possible to have the same type and same name in the argument, right? In the parameter, you cannot have string name and string name, right? You cannot have twice. Only once you can provide it here. So so this is one of the drawback of class-based projection compared to interface-based projection, right? So let's run one example. If you see here, we are getting the desired input. Okay, we got the desired output, and I will do some R&D here. Okay, in this query, I will go here. I will modify something like this. Okay, so I will make it to namex. Will it work? Let's see. Okay, so it is unable to recognize the column name namex, right? There is no property it is saying. So what we can do is we have to undo it, and for now, I mean, we got to know that the column name must be, I mean, the parameter name must match with the column name, right? That is the rule here. And already you have seen this one, right? This need not to match with the column name, right? So this is with the custom query. We can also run the query method. Okay, we'll go to the application. I will comment it out. Okay, I will uncomment this one. Run it. So it is also working, right? And if you see here, so this one particularly, this one is a query method. So class-based projection works with whether it's a custom query or query method works with both the query types. Okay, the next one is nested projection. And nested projection is not allowed in class-based projection. Okay, so for that I have created one example. So I already have commented that it won't work. Okay, I will comment this one. So below for nested projection won't work. So still to prove the concept, I have to run this one. So what I did is I created a projection. This is a projection class. Inside the projection class, I have an object type. Okay, category is an object. Category DTO. If you go to the category DTO, this itself is a projection, right? But it won't work. Nested projection won't work in class-based projection. Let's run this one. Okay. See unexpected token, all these things because it doesn't support nested projection, right? So the ideally I was trying to write here is I will write the column name first, and the next one is the entire table I was kind of fetching, right? So that is not possible. So that is the reason nested projection is not allowed. I will comment it out so that it won't throw runtime error to me. So I will go to the document. So class-based projection, nested projection is not possible. That we already tried. And the second one is when using class-based projection with query method, property name need not to be same as column name, but constructor parameter name need to be same as column name. Okay, that is applied for both query method as well as custom query. Okay, both it is applied to both. So next we will see the dynamic projection. So in dynamic projection, we have 2 points here that we need to remember. dynamic projection work with derived query or query methods automatically. Okay. For custom query, Spring doesn't support dynamic projection. So let's understand this concept by executing some of the queries. So let's go here. The whole concept of dynamic projection is that um, the query which we write, okay, and the object that returns, basically the projection that it returns is dynamic. So it can take any kind of projection, right? That is the concept of dynamic projection. So we'll just write some example. Here we have. I will go to this query. Okay. So here I have written a query where this is a custom query, right? So I already told you with custom query dynamic projection won't work, right? Because you already have defined the columns, right? So how it is dynamic? It is always static. You will be getting the same this one projection always, same kind of object always, right? So there is no point of saying it is a dynamic query. But still, the reason why I'm executing is you will get to know here. Let's run this one. Okay. So we are getting the result like only the names we are getting. Okay. Only the names. We go to this one. So I have created an interface and I have provided only one property, that is name, right? Get name. So that is the reason it is fetching name. But 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 even though I am fetching one column, right? If you see the query generated by the JPA, so it is fetching name, price, and category. The reason is I already have defined those things in the query. Go to the query, they see name, price, and category, or everything I have defined, right? That's the reason it is fetching all the things. Now with the same query, okay, I will use the same query, but with a different projection. And this time the projection is um, projection category projection, product category projection, where there are two properties, name, price, and get category object. Okay. Even though I'm using the same query, but the return types are both different. Now run this one. I will comment it out the above one. Okay. If you see here, it is returning the result that is expected, and the query is same as before, right? But this is not a dynamic projection because here we are using the same query, but the return type is different. Not because of the support of the dynamic projection, it is because of the Java basically, right? Java we have defined this one as dynamic return type, right? So because of Java supports dynamic uh, behavior here, it cannot be said it's a dynamic projection. When we can say dynamic projection, when we can provide both interface based projection as well as class based projection. That time we can say a query is dynamic projection query, right? So let's comment it out. So the next is the dynamic projection. So in dynamic projection, we have query method. Okay. If you see here, the return type is T. Okay. Now we'll execute this one, right? So what is this? It has name and price. We are just fetching two columns. Okay. It's a class based projection. Let's run this one. Okay. So it has written us name and price. Okay. If you see the columns also, there are two columns only, not more than that. It is not fetching whole table, right? Now we'll go to the second query. We'll reuse the same query here, derived query. Okay. The query method. Same query. Okay. Now here I will use a different projection altogether, right? Here I will use this one. I will fetch all these things. So let's run this one. Okay, it is fetching three columns right now. Okay, if you see here, one, two, three, all the three are fetched, right? So this is a dynamic projection, right? I mean, it is up to us whatever the projection will provide to the query. As per that projection, it will fetch. Suppose in that projection we have three property, it will fetch three. If it is two, it will fetch two, right? It's dynamic projection. We can pass interface as well. So in both the above cases, I have passed DTOs. Now try to patch using the interface. Let's run this one. I will use an interface based projection. Okay, if you see, if you see here, this is a this is an interface. Okay, so I will use this one having the same query. So far I have used, right? This is a derived query. I will use the same query. I will run it and it will work, right? So that is the reason here I have mentioned in the document this dynamic projection only work with the derived query or query method. It doesn't work with custom queries, right? When you write custom query or DTO based or class based projection, that time you are very specific to the column, right? You have to mention it explicitly. You have to mention it, and that cannot be dynamic, right? So that is the reason dynamic projection only works with derived queries. So the next thing we'll discuss about the open projection and closed projection. So open projection, what we can do is can include computed fields and use value annotation with special expression, allowing combining multiple fields into a single projection method, right? So these are all the things we can do in open projection, right? I will give you an example. So if you see this, I created a projection, okay? Interface based projection, right? So if you see here, category name, how I am retrieving it using a value annotation, using a value annotation. Similarly, the get category price, I'm kind of computing here, right? Target dot price is greater than 1000 means it is expensive, otherwise it is affordable, right? So when you do such kind of operation inside a projection, it is called open projection. And what is closed projection? A closed projection in Spring Data is an interface projection that only include explicitly defined getters. So far, whatever we have used, right? Interface based projection here. So far, whatever the example we have used, all are all comes under closed projection. So for this, there is no need to uh, execute any special program or example, right? So with this one, we can execute. So we can go to this application. So this is one thing I created. Find by category name, and the projection is interface based projection. And here how you are computing things, right? So let's run this and we'll see how the output looks like. See, so it is printing the name of the product and price, right? And the category, right? And whether it is affordable, right? All these things are comes under this computation, and fetching data is comes under the open projection, right? So this all so far we have covered is projection, right? Um, the first we started with interface, then class based, then dynamic, then open, then closed, right? So all things of this projection is completed. So right now, if you see here, I have given SQL query to prepare to create these tables so that you can execute in your local machine and you can create those tables and you can insert some sample data, right? So for that, for the convenient purpose, I have given this one. So you can use this, and all the examples whatever I have executed so far, I already have included in the Git repository. That link I have already provided in the description. You can go through it. You can download the source code and execute it. So this is all about projection. Thank you.